Your FastMCP server needs to validate tokens, but you don't want authentication logic scattered across different environments and deployment configurations. We'll show you how to centralize all token verification settings, whether using JWKS endpoints, symmetric keys, or required scopes, through simple environment variables, making your deployment consistent from development to production.
Hash-enabled JWT verification. Export fast server auth equals FastMCP server auth providers JWT verifier. Hash for asymmetric verification with JWKS endpoint. Export fast server auth JWKS URI equals https://auth company com/ well-known /JWKS JSON. Export fast server auth JWT issuer equals https://auth company com. Export fast server auth JWT audience equals MCP production API. Export fast server auth JWT required scopes equals read data write data. Hash OR for symmetric key verification HMAC. Export fast server auth JWT public key equals your shared secret key minimum 32 chars. Export fast server auth JWT algorithm equals HS256 hash or HS384 HS512. Export fast server auth JWT issuer equals internal auth service. Export fast server auth JWT audience equals MCP internal API.
This demonstrates environment-driven configuration for token-based authentication, following the externalized configuration pattern. The approach separates security policies from application code, allowing authentication mechanisms to be defined through environment variables rather than hard-coded implementations. What makes this distinctive is its ability to support multiple verification strategies, JWKS endpoints, symmetric keys, or static tokens, without modifying the core application logic. The pattern works by treating authentication as a pluggable component where the specific verifier implementation is determined at runtime. Environment variables define which verifier class to use, like JWT or introspection, and provide all necessary parameters, keys, endpoints, required scopes. This creates a clean separation between the application's business logic and its security layer, enabling different deployment environments to use appropriate authentication methods without code changes. This approach matters because it solves the problem of environment-specific security requirements in distributed systems. Production might use JWKS endpoints for automatic key rotation, while development uses static tokens for simplicity, all controlled through configuration. The trade-off is slightly more complex setup, but the benefit is complete flexibility in authentication strategies across different deployment scenarios, from microservices to external-facing APIs. Let's break it down line by line.
Hash-enabled JWT verification. Export fast server auth equals FastMCP server auth providers JWT verifier.
This enables JWT authentication by configuring FastMCP to use the JWT verifier provider. Without this, the server would accept unauthenticated requests, creating a security vulnerability. The pattern follows FastMCP's pluggable auth system, where you specify the verification strategy via environment variables.
Hash for asymmetric verification with JWKS endpoint. Export fast server auth JWKS URI equals https://auth company com/ well-known /JWKS JSON.
This configures JWT verification using the JWKS endpoint pattern. The server fetches public keys dynamically from this URI to validate tokens, eliminating manual key management. Required for asymmetric JWT verification, where keys rotate periodically.
Export FastMCP server auth JWT issuer equals https://auth company.com.
This sets the JWT issuer claim to validate against. It ensures only tokens from your trusted authentication authority at auth.company.com are accepted, preventing spoofed tokens from unauthorized sources.
Export FastMCP server auth JWT audience equals MCP production API.
This sets the JWT audience claim, enforcing that tokens must explicitly declare this API as their intended recipient. Prevents token reuse attacks by rejecting tokens meant for other services, even if they're otherwise valid.
Export FastMCP server auth JWT required scopes equals read data, write data.
This enforces scope-based authorization by requiring specific auth2 scopes in the JWT. The server will reject tokens missing either read data or write data scope, implementing fine-grained access control at the API level.
Hash-OR for symmetric key verification, HMAC. Export FastMCP server auth JWT public key equals your shared secret key minimum 32 chars.
This defines a shared secret key for HMAC-based JWT verification. Symmetric verification uses the same key for both signing and validation, requiring secure key distribution, but eliminating the need for a JWKS endpoint.
Export FastMCP server auth JWT algorithm equals HS256 hash or HS384, HS512.
Specifies the HMAC algorithm for symmetric JWT verification. HS256 uses SHA-256 hashing, while HS384 and HS512 offer stronger 384-bit and 512-bit security, respectively. This setting must match the algorithm used to sign the tokens, or verification will fail.
Export FastMCP server auth JWT issuer equals internal auth service.
This sets the JWT issuer claim to validate against. It prevents token spoofing by ensuring only tokens from the specified authority are accepted, a critical security check in production environments.
Export FastMCP server auth JWT audience equals MCP internal API.
This sets the JWT audience claim, enforcing that tokens must explicitly target this API. Prevents token reuse attacks by rejecting tokens intended for other services, even if they're otherwise valid. Environment-based authentication. FastMCP's JWT verification through environment variables implements the 12-factor app principle of strict separation between config and code, enabling identical deployments across development, staging, and production with zero code changes. The symmetric key configuration uses the misleadingly named public key parameter for HMAC secrets, which can cause confusion if not documented. This pattern eliminates deployment friction by making authentication an infrastructure concern rather than an application concern.
The environment variable that disappears from your code becomes the foundation of your security.